applications we can develop with those technologies, and maybe even more exciting is what's coming up. Another important, couple of important applications that are also being developed on this one. For example, the HRRN cluster in Berlin and Hanover, the pressure dance system of NASA and CEA, GENSI cluster, etc., etc. And also the one which is very important here, the LZ Jülich, which is the Forschung Zentrum Jülich, that has also decided to go with this kind of technology and those architectures. And there are two major clusters that are being developed at this university, at this development center right now. One is a 1992 computing node with 16,000 cores that will develop 200 teraflops of the performance for general purpose computing for research and development. And the other one is an HPC for fusion supercomputer, which is about finding new energies, sources of energy going into the future. But for this, you need to do a lot of research and development, and it's a high-performance computing structure and a cluster that will be developed around this technology here. Another partner who is building another HPC cluster of similar size is RWTH Aachen. And for this, I would like to welcome Dieter and May just to tell us how he's doing this and what he's doing with this technology.
So we have close cooperation with our clients, and actually we're building up a similar size cluster in the near future. So actually, we just had a procurement which was run by Sun Microsystems providing large clusters. They would be all equipped with all processors. We just set up online storage, and we're patiently waiting for the first day holidays to come in spring. This will be a 200-node cluster. And once we finalize the extension building that we have to set up first, because we don't have any more room for computers right now. So in 2010, we will fill these new rooms with more Mihalens, and they will account for 200 teraflops and 60 terabyte of main memory. So actually, this will be a very nice platform for our scientists. Aachen University is pretty much a technical place. There are 30,000 students and thousands of scientists. Half of them are engineers. 1/4 is natural science and computer science. So we have a very high demand for compute power, basically infinite demand for compute power by the engineers. And they will be very happy using this facility. So those nodes, they will be connected by a very fast InfiniBand to our network. So this is a very nice platform for message passing, which is one of the big paradigms to parallelize applications. But also the quick path technology that Intel is providing allows Intel basically to plug together multiple processors to one shared memory, which is very important because this offers another opportunity for parallelization, shared parallelization. We typically use OpenMP, which is the de facto standard there. And this is very attractive for the engineers because parallelizing with OpenMP means they don't have to change their read codes so much than the normal MPI. So we provide both, and in many cases this will be combined. There's another important thing that I'd like to mention. So we want to increase productivity of the users. So we want to provide them with their favorite environment. And they've been asking for Linux and Windows. So one of the requirements for the procurement was that the majority of the nodes should be ready to run Linux and Windows. And we're very happy that now all of the nodes will be able to run Linux and Windows and Solaris as well. So from the desktop to the high-end machine, they will have the same familiar environment, which is very nice to push computational science forward. And we're very happy with that.
Very good. Thank you very much, Peter. And I'm sure a lot of this computing power will be used by the students who need increasing power on a daily basis.
I think it is our task to really teach students and scientists to move forward, because software development takes so much longer than the hardware development cycle. So these large codes, they typically are developed in decades, like 1 or 2 decades, 100,000 or maybe a million line of codes. So you'll have to really be prepared to go in the right direction at this point. Trust me.
Thank you very much.